Hello, I am Michelle Davis of the Center for Manufacturing Research at Tennessee Tech University in Cookeville, Tennessee. Welcome to the Fall 2020 Golden Eagle Additively Innovative Virtual Lecture Series. This is the 10th semester we have produced this popular and informative series. The series is hosted by TTU's Center for Manufacturing Research and the iMaker space at TTU. Additive manufacturing is a focus of both entities, and as such, this short virtual lecture series has been planned to highlight the best practices, potential problems, technological advancements, innovations, and scientific contributions in additive manufacturing, with expert talks from various institutions, industries, R&D centers, and laboratories. Today, we are honored to hear from Steinar Killi, professor at Oslo School of Architecture and Design in Norway. His talk is titled New Product Development for AM, Methods and Tools. The speaker will provide his contact information for questions after the presentation is over. Thank you, and I turn the presentation over to Steinar.
Thank you for giving us this audience to talk about new product development and additive manufacturing. Also, welcome to the Oslo School of Architecture and Design. My name is Steinar Killi.
And my name is Stine Sofie Schillo.
In the next about 30 minutes or so, we will show you, what will we show you?
Yeah, you will have an introduction to the topic, and we have also made a movie that we want to show you about new product development and additive manufacturing. And after that, you have interviewed two companies, one startup company and one super brand. And in the end, we will come back here and summarize everything.
Let's get started. So what is new product development, or NPD? It's two interpretations of this term. It could be the way we develop new products or how we develop new products. The first one would imply that there are an old way of doing it, which is kind of true. The old way of doing product development was all about technology driven. The way we develop products today is more user needs driven, and so on. In this talk, I will talk more about the more generic part of new product development, how a new product are developed. To be more clear about this, we can divide the whole process into 4 steps or 4 phases. The first part is the fuzzy front end. Here is where everything starts. Here's where the inspiration comes. Here's where the boundaries for the projects. Market people are in at this stage, saying what's needed in the market, user insights, technicians will be present to say, talk about any new technology, and so on. Trends will be discussed, and this phase ends up with what we could call a brief. And the brief is what the designers take with them into the next phase, which is the product design phase. Here, concepts are developed based on the insights and the brief. So the designer's task now is to come up with concepts or solutions that is an answer to the brief. And when a concept is kind of found and evaluated to be good enough to go into the next stage, which is production preparing. At this point, it's all about making that concept producible. That means going all the way down to nuts and bolts, making the tool, getting down the cost, finding the exact material, and this part is typically led by the technical people. And of course, designers will be part of it because maybe the design has to be altered slightly and so on. And from this stage, we move on to the last stage, which has the name fuzzy back end. And this is the final stage. Here's where the actual production starts or goes on. And it's all about bringing the product to market, where it's going into stores, it's going to be produced in-house, on license, if you're going to buy it online, lease it, and so forth. So this part is usually the market department that handle this. So what is the connection between new product development and additive manufacturing? We need to go back some years. And if you go back to the beginning of 2000, when the term additive manufacturing came about, this curve shows very nicely the difference between the classical production methods like injection molding and different kind of additive manufacturing methods. The curve shows, and I guess a lot of you have seen this curve or this graph before, it shows how injection molding price per part starts out really high because you have to write off the tool, but the more parts you make, the cheaper the production cost will be, compared to different kinds of additive manufacturing methods where the price per part is pretty much stable. It's not cheaper per part to produce one or 100 or 200 or so forth. Of course, this is not quite true because if you produce several in one batch, you will probably have a lower cost price per part. But the additive manufacturing line is pretty vertical or quite stable, straight line. But it's not that simple, because when you're going to produce very few parts, which is kind of the sweet spot of the additive manufacturing part, you know, before the lines are crossing and it's cheaper to use injection molding, we don't count in the design cost. When you look at ordinary injection molded parts, all costs are divided to each part. It's not just the molding cost, it's also developing cost, the design cost, and everybody else that's been doing something with the product. And that's been divided per part. And the previous graph didn't show that part of the product development at all. To kind of illustrate this, we did a little project 5 years ago. And what we did was to design a phone cover. Probably many of you had done that before. A simple cover that you see on the left that we then, after designing it, sent to one production facilities that gave us a price on tooling for injection molding, and we also sent it to Shapeways for get a price quote on additive manufacturing. And then we added up the different costs, material, labor, production, and so on. And then we see the two curves, and now the curves looks much more similar because now we had to write off the actual cost of the whole production process. Still, the additive manufacturing has a skewed to the left because still it's cheaper because it doesn't have any molding cost, but it's not that cheap that people maybe think. But are we there yet? Probably not. So to continue this discussion, we will have to do another little test. So now we're going to see a video of an experiment we did at AHO, and we'll be back soon.
Hello, my name is Raquel Troya. I am pro-rector here at the Oslo School of Architecture and Design.
My name is Sarah, and I'm at my 5th year at AHO at the master's course in industrial design.
Hello, my name is Gary Jensen. I work here at the workshops at AHO.
I have a design challenge for you. We've decided in the communication department that we would like to produce some merchandise for AHO that we can use to promote AHO and strengthen the brand and knowledge of the Oslo School of Architecture and Design. And we thought it would be nice to make 2 different telephone covers, and we're going to use them both as giveaways to collaborating partners and so on, but also sell them in the reception. That's the plan. The first one will be injected molded, and it will be a simple solution to fit the iPhone XS. And we imagine that that one will be produced in a higher quantity and will therefore also be able to be sold for a less expensive price than the second one. And we'd like the second one to sort of add some additional value and be a bit more high-end. We see it as being 3D printed and that it can be adapted to different telephone models that people have. perhaps it could have an extra additional feature. For example, the identity card from the employees could fit inside, or credit cards that you want to carry with you. Does that sound clear and good, so that you can start exploring the opportunities and possibilities? Good.
So after getting the task, I like to start with just mapping out the whole area that I'm working with. So since I'm working with iPhone covers, just looking into what is today, looking at injection molding. I haven't done that a lot before, so it's nice to just get into that. And also just looking at 3D printing and looking at what can I use from AHO's logos and pictures in the merchandise. I think I will start with the concept for the injection molding. Two kind of separate concepts. This concept is about having this graphic statement look to it, and in this example I've used the subjects at school here that you can see through the letters.
Here you would see the actual cover color of your telephone.
Correct.
Through. And nice, the idea of playing with words and actually communicating some of the content of what we do at this school out to a general public. So you might have to reconsider some of the use. I think you need to do another iteration now of looking at which words and then look at the positioning and also the way the type runs.
Over to the 3D printing concept. To the first concept, I've just called the concept for layering. I'm looking at layers. If there are layers in the structure that you can slide the card within two structures, or that the structure in itself kind of hides parts of the card, but also shows something on the card that you want to show. So this is just an example that if you slide the card and you can see something, and this is of course just one hole, but you can have several holes in the structure. This is more about using the structure of 3D printing, for instance, parametric structures or generative structures in different ways. You could use the structure, for example, in this case, to add more structure where you need strength on the case. So the whole case doesn't need to be solid. You can have more strength, for example, on the corners, because that's probably where you need more strength and less structure in the middle. Or you could use the structure to create a logo. It should be more subtle than this, but you get what I mean.
I think it would be nice to see another iteration exploring this and really having the logo be tactile, be discreet, and yet, like I said, sort of celebrating the opportunities that the 3D printing allows for.
It is a nice solution, but it's rather costly because you need to make a tool which is it's a more complex tool than we figured out at the start, because it has these overhangs on the edges. So the lettering, which is going through for getting the flow or injection molded plastic to flow nicely, and it would be a challenge with all this kind of
the detail in
yeah.
the cover.
Yeah, so this is the 3D printed version.
Cool.
It looks nice, and also the added benefit of placing the card. And the price would be approximately 16 euros.
16 euros
Yeah.
for producing or print this cover.
Yeah.
And then we were going to have some paint on it. Sarah is going to get paid for her time, so we probably at least have to double the price.
Probably.
Yeah. So it looks quite nice, doesn't it?
Yeah.
Cool. There's a lot of things we could discuss after watching the video. One of the things that I want to lift up here is kind of the background for the curve that you see on this slide. You recognize the two covers that you saw in the video, and if you try to make the curve similar to the one we made in 2015, you see that the shape of them is pretty much the same. But the big difference here is the design of two different covers, because there is no point of designing a cover for injection molding and then look at what the price would be for additive manufacturing the same cover. So what we did here was to make two different designs, one to be injection molded and one to be additive manufacturing. And then we can compare which kind of design should we go for, as you saw in the video. So comparing apples and pears, which is actually what we're doing now, and the previous one we were comparing just apples, is probably a more correct way, because you need to decide when are you going to make the decision of, are you going to make an injection molded or are you going to make an additive manufacturing cover? Because in many ways, additive manufacturing has been addressed mainly around the third section in the new development of products: the production preparement, the engineering part, and in production. Usually, this is the area where we are seeing a lot of work recently. There are some kind of part, and it's been modified and enhanced, less weight, and you can get a part that is more suitable, lower weight, and all this. But now we are pretty much in the third stage. The design has been decided. The question is, could this part or the problem it's solving, its functionality, being solved totally different instead of adjusting the design in the part 3? And this is pretty much what we see in a lot of senses how we're using additive manufacturing today, is either enhancing the design or we use it during production. To get further on this thing, we found it would be interesting to have a little talk with two companies that are actually using additive manufacturing to a large extent. So we contacted two companies, one startup company run by Ricardo Simian. So we'll hear an interview with him first. So let's watch that. I would like to welcome Ricardo Simian to a short talk. He's the founder of 3D Music Instruments. He also won a prize, the Pemundus Prize, in 2018. As far as I understand, you started out by bringing kind of all the instruments back to life using 3D printing, wasn't it so?
Yes, so I studied early music. I was specialized in early music, and that's a pretty weird field because we're trying to recreate the music from the past, and therefore we rely a lot on museum objects, and it's very interesting to try to make instrument sounds when you're not even allowed to touch them. They are behind a glass in a museum. So 3D printing was a very interesting, and it's still a very interesting alternative in order to copy those instruments or reconstruct those instruments and make them sound again.
But at some point you also started to develop your kind of own designs too. What was the reason for that?
Instrument making is a weird area because many things come together. The design, the functionality, the physicality, the ergonomics, the questions which collide within that result come from tradition, come from practicality, but also from technical limitations. So if we are really honest about it, musical instruments are made out of certain materials, not because that's necessarily the best material available today, but because it was the only, usually, material available 200 years ago or 400 years ago. That's why brass instruments are made out of brass. That's why string instruments are made out of wood, because there was no other technical solution. So once you open to the possibility that you can produce them in a different way, for instance, through additive manufacturing, you have opened the Pandora box. And then you can open yourself to do things in a completely different way once you have overcome the technicalities.
And you're also playing the music yourself on your instruments, don't you?
Well, not all of them, because I started, of course, producing instruments that I can play and test myself. but you can only play a few instruments, and then you need to start expanding to the instruments that you don't play yourself, and you need to start relying on experts, external experts and inputs in order to develop the instruments, and that makes the whole development testing process way more complicated.
When it comes to the actual design, how do you go by when you are designing, since you kind of are ending up with something that's going to be printed and not mass produced? How do you think?
The niches which are very interesting for us are the ones of the forgotten instruments, or the personalized instruments, or the instruments which are not required in mass production numbers, but still required. Those instruments which move in the hundreds. That's kind of the soft spot that you described in your book. Usually the process starts with a replica of an existing traditional instrument. And from then on, you start testing what can we improve, what can we done in a different way. It's quite an, I would say, even Darwinian evolutionary process, step by step, testing what can be done, and always using what you have learned from the previous experiments in order to accelerate that process and see where can you extrapolate, in which directions can you move. So one thing which is important, for instance, for the wind instruments is that the shape can be thought in a much more freer way. So if traditional instruments look like this, just basically it's an inner bore, an air column. It doesn't matter if then you bend it like this acoustically. So once you acknowledge that, the design process can be way freer. And of course, solutions like this one would have never been considered in any traditional production process, because there's no way to produce this by hand. There's no way to make a mold for it or to carve it out by hand.
I mean, you've been working so kind of close to the 3D printing technology. What do you think are the issues that has to be addressed to bring this forward and make it even more useful, in your opinion?
How unpredictable the technicalities and the problems are. Because sometimes you increase 1 millimeter an object, and that means jumping from one machine to a different machine, or not having yet a solution for a certain material, or you may have the perfect surface, the perfect density, but it's not a material you want to put in your mouth. It's in the case of a musical instrument. So this matrix of elements which cross in a very complicated way, it's quite unpredictable. And for me, the main problem actually, and that's not only for the musical instruments, is that people don't yet integrate the new possible solutions. People don't yet know, clients don't yet know that it is possible to do something in a radically different way, in a different production scale, and in a much more personalized way. Therefore, they already, because of experience, you know that if you're going to build this building and you're going to have this lighting, you're either going to use these mass produced ones, or you're going to order them to be done by hand, one by one, with a huge production cost. And you don't think, well, actually we could produce 500 of these with 3D printing in a personalized manner. And that, even though that's absolutely possible, and it has been possible for years, still architects, designers are not integrating that into the thinking line because they haven't yet realized it's possible. We're in that uncomfortable gap where something is technically possible, but people haven't yet realized, like the many years we kept sending things per post, even though email was already around.
Great. I'm really thankful, Ricardo, that you could take the time. And please, I have to ask you if you can play a little thing on your instrument.
Yes. Well, I would like to make a short blind test if you want. So if you want to close your eyes, I'm going to play 2 instruments. And one is going to be a traditional one with a very traditional material, and the other one is going to be entirely synthetic, not only 3D printed parts. So I'm going to play one instrument now.
Okay, we close our eyes.
I'm now going to play a second instrument.
Again, thanks a lot.
Thank you.
Yep. Bye.
Bye.
Ricardo made a lot of good points. We will sum them up in the end of this talk. We'll move quickly to the next interview. And let's hear what he has to say about some of the same questions that we talked with Ricardo Simen about.
Thank you, Klaus Olshoff, and you are a communication director in Adidas. I mean, Adidas has been using 3D printing for a long time, all the way back to the 90s. But at some point, you found out that you actually want to use it for production, and you came up with the first concept models with the sole printed. Could you say something about what kind of made that decision for you?
You have to really go like 20 years ago, and prototypes and models were made by hand, free-form modeling, and that was always our special thing, because if you look at shoes, they are three-dimensional objects which are shaped and morphed and have various, like, such a rich detail in surfaces, which was not possible that time to really build in a digital way. Like 10, 12 years ago, we started to go into 3D, just still in the mock-up phase, in the mock-up shops. We had these wonderful three-dimensional objects, and people were permanently breaking because they thought it's a shoe, it's a sole, knack, it was broken. So durability was a key thing. A sidestep to that, how we are working, Adidas has a very, I think, successful communication tool we call FutureCraft. FutureCraft for us is not ready production processes which are actually show the intention, have an inspiration, bring coolness to an object, and show a little bit glimpse of that what we might do in the future. So it's a platform for us to test in the public ideas which are not yet producible. And one of the first FutureCrafts was we called it FutureCraft 3D. That was sintered nylon material. It worked, but it broke. Because if you want to use it as a shoe, really in its natural environment, it's very surprising how durable things have to be and what the mechanical and technical loads on the materials are. Now we are actually in a phase where we can produce parts in production scale for hundreds of thousands of pairs, and that is actually scaled and possible to use really for end consumer products. Material is now there.
We're also talking about this new product development and kind of that method and that thinking. How did it start for this kind of shoes? For instance, the one I was holding up here. And how do you see that kind of start being when you're moving forward into using 3D printing as a production method?
Now we can do things which can be on demand. We can produce products which are unproducible in the technical specifications in a way, at least from geometry perspective. Using 3D geometries as cushioning systems, they are working actually quite well and very well, and they don't break down. So the material is very key to that, but also you have to look at the person using it. The loads the human being puts through a foot stride in research data, at foot stride data, in pressure maps, you see a colorful image of different pressure zones. And if you go through the traditional production processes and the way how you go through a fuzzy front end, you look at product design, product production, fuzzy back end. It is very apparent that we now have at all levels another column next to it. It's data. So each of these phases in production do generate data, use data. And we also have user data. Actually, that information we implement in the briefs and also which informs the way how we make our product is actually feedback data from the market. And it's not like having written reports and the user likes it or doesn't like the yellow. It is really about, it's really about measured information, and it's about prediction of market behaviors and how users will act in the future in changing dynamic living scenarios and so on. So there's a lot of information and data out there. So if you talk about 3D, of course, it is accelerating certain things. So individualization could be easily implemented into products we are producing. But on the other hand, the production process itself takes longer. And you cannot compare additive manufacturing with an injection molding machine, which spits out hundreds of pieces in a minute.
Thank you so much for doing this and trying to, or giving us some answers and some new questions, I think. So I'm very obliged. Thank you.
So how can we summarize this?
Well, it was a lot of information, and I think that we kind of got some good explanation of what we are talking about, I hope. We started out with a video, which kind of reflected a little bit, but also exemplified quite nicely the difference between injection molding and 3D printing, both during the design, but also during the next phases.
Yeah, and it was really nice to see Ricardo playing. But what do you think are the main points from that interview?
Well, Ricardo made several points. One of the most important, I think, was that the way he talked about materials, that you could have, that you're using materials because we've always been using it. We don't think about actually it could be made in a different material. Also, he was talking about the Pandora's box. Usually you shouldn't open Pandora's box, but I think he actually said that you should do that, and that's probably some of the problem, that people doesn't dare to open the box and actually try what this production method could give to the whole product development process.
And also talking to Klaus, it was interesting to hear how a superband used this method.
To some extent, he confirmed a lot of things what Ricardo says. He also said that the process is now at the point where the quality and the time is in line with the ordinary way of producing. One of the key points he also talked about was data, consumer data, data used, and how this kind of influenced the whole new product development process. And it's interesting to see kind of how superbrand are actually talking about making shoes by the 10,000s or even 100,000s, even though it's still in experimental and developing. So all in all, I hope that this was half an hour, which gave you some insight into new product development and how additive manufacturing could influence this process.
Thank you for your attention, and you can see on this page our contact information.
Thank you.